property of a convolution. Okay, so when can you say a particular algorithm is efficient in convolution? Convolution means what? What is meant by convolution? Convolution, we are using the term convolution, right? What we are actually doing that neural network. Convolution.
Reducing.
Beyond. Okay, reducing is another. Okay, commonly beyond transforming, right? So it is the meaning of transformation. Okay, so this is the property of convolution. If this property is achieved means a particular algorithm can be said as efficient convolution algorithm. The meaning is, which is very simple. Here we have a function. This is a transformation function. There are two different units. If two different units, complete transformation is equal to single unit transformation into another second unit's transformation. So imagine our problem which we have solved in the previous classes. Take that same problem. You have a input image which is 5 cross 5, right? And we have a kernel that is 3 cross 3, isn't it? So when you are solving with strides, different strides, when stride is equal to 1, whatever, you can take either stride 1 or stride 2, whatever, right? So first thing is, you will be taking this part and you will be making product with the kernel, right? Am I right? So for this, you will be getting a value of 12. For example, you are getting a value of 12. So individually, you are making a function. Finally, on the whole, then next we are taking this part and we will be taking product with the kernel and we will be getting answer here, right? Am I right or not? So individual products will make complete transformation of the input image, right? So that is this property. So if you have two units, individual transformation, the product of the individual transformation is equal to the two units complete transformation. This is like our output, final output. So if you do individually also, if you are doing transformation as for first unit and second unit, if you take the product also, which will be equal to the final output. So that is property of convolution. If a particular algorithm satisfies this property, we will be calling that algorithm as efficient convolution algorithm. F means transformation function. Okay, F and G, small f and g are big. These are small input units, right? Input units. Okay, so you are reducing the dimensions from the input to output, right? So when you are reducing, the base thing is we are reducing the computation also. The problem, isn't it? So in order to reduce the computational cost, three different techniques can be applied in the convolutional neural network. First thing is, we can able to initialize randomly so that we can able to reduce the number of computations. The second one is hand designed kernels. We can able to have hybrid kernels. The third one is, there is no mandate to use only supervised here. We can able to apply unsupervised learning approach also. If we apply three techniques, we can able to reduce the computational cost gradually. Then another approach to reduce the computational cost during the training. Training part is very difficult. So you are giving an input as test image and it is classifying, which is very simple. That is testing part, right? Just it is classifying a particular image, whether it is a car or bus, whatever it is. But training is very important. Our algorithm will work basically in training, right? So because it will take all the features of different images and it will learn how to classify. So training is very important. So for training only we will be getting more computational cost. So in order to reduce the training computational cost, we are using this methods. Another approach is to reduce the computational cost in the training part. So what is greedy layer approach in the sense? You have different units, different neurons in the input layer, right? So each unit will be taken separately, each will be trained isolatedly, then we will be combining in order to get the complete model. Okay. So instead of taking completely, each and every layer, different layers. First layer will be trained. Then next one. Likewise, each and every one will be separately trained. Then on the whole, we will get a model. That is the concept of greedy layer approach. Okay. So our next topic in neural network is spiking neural networks. Do you have any guess by specifying this name? Spiking neural networks. So in normal perceptron or multi-layer perceptron neural network, we have values, right, in inputs. So for example, you have two inputs x1 and x2 and associated weights w1, w2 means you will be having input values, right? Input values. Am I right or not? So we have we did many problems, right? How do you solve this problem? x1, x2, w1, w2. You will be having y1. What is the computation part? y1 is equal to
x1 into
w1 plus x2 into w2. You have values, so you will be taking the product, then total summation is equal to the output, right? So instead of this, a series of events will be taken, series of spikes will be taken as input, and the central processing part is similar, same. You will be getting series of spikes or spike trains as output. Each and every spike is nothing but a particular event on a particular time in a particular space. Okay? So, taking series of spikes as input and processing to get series of spike or spike trains as output, that is the core concept of spiking neural network. Same procedure. We have input layer and hidden layer, output layer. We have to enter through input layer for getting inputs from the environment, right? Same procedure. Instead of having the values, here we have x1, x2 as values, right? Am I right or not? Which are single, isn't it? So instead of that, here series of spikes. Spike is nothing but this is a spike. This is another spike. Each and every one is an event at a particular time on a particular space, on a certain space. Got it? Yes or no? Yes? Got it? So what is the input of spiking neural network? Input is any input. Be louder. Values. Be louder. Inputs. Again and again I am telling, here we don't have a single value for inputs. Series of, you know the meaning of series, right? Series, right? Large number of, okay, series of spikes as input given to the input layers. Then it will move on to hidden layer for processing. Then the output of hidden layer will be given as input to
output.
From the output layer we are getting again series of spikes or spike trains as output. Got it? So this is represented as single spike, which is nothing but a particular event. One event at a particular time on certain space. Okay. So the procedure is same, but you have to consider the input and the output part. So why this spiking neural network is developed in the sense 1952 itself it was developed by Andrew and Allen. So they created a model most similar to the biological neuron. So they tried to create more similar to our biological neuron so that they have created the spiking neural network. So we'll be processing in our mind. So each and every event separately, right? So likewise, each and every spike is a one event, and it will be on the whole taken it as input and process output series of spikes. Got it? Here also, listen. Here also we can have three groups of neural network: feed forward, recurrent, and hybrid one. So what is meant by feed forward? You know the meaning, right?
Moves only in one direction.
Feed forward means
Only in one direction.
yes, be louder. Only
One direction.
one direction. Starting from the input through different hidden layers, then we are getting the output. So that is feed forward. Only one direction. Next one is
Recurrent.
recurrent. Recurrent means I don't need this answer, director. What is the meaning of recurrent actually? Recurrent neural network means some kind of output in between. We have different hidden layers, right? Some input layers out, some hidden layers output will be given as feedback to the previous layers. That is recurrent. So, if it is moving forward, only means that is feed forward. If feedback is given back to previous layers, also means that is recurrent neural network. So we are representing a directed graph. The last one is hybrid. Normally, this hybrid word in algorithm terms will be used for you are having one algorithm. Okay, algorithm A and algorithm B. Okay, so if you are going to find out a new algorithm, okay, new algorithm based on two different concepts. Taking pros of A and taking pros of B, we are going to create a new algorithm, means that is hybrid. We are using different concept, we are going to create a new one, that is hybrid. Normally we will represent this the term hybrid in algorithms. Okay, hybrid algorithm. So here two different hybrid algorithms available: sync-fire chain and then reservoir computing. Sync-fire chain is similar to feed forward, right? Synchronous way of trains. So synchronously in the sense the same line, with the same line it will be going through input, process and output. With the synchronously, that is synchronous sync-fire chain. Synchronous way of transmission without any repetition or recurrent. Okay, the next one is reservoir computing. Reservoir computing is in spiking neural network. Feedback of a particular layer is given back to previous layer also. That is reservoir computing. So it is similar to feed forward. This one is similar to recurrent. We have different names only. What are the two types of hybrid spiking neural network? Sync-fire, reservoir computing. Got it? Have you got any idea about spiking now? What is the core idea? It is also a kind of neural network with the same process, but here we are having
Series of
spikes as input and it will process through different hidden layers. Finally, we are getting
output.
Series of spikes or spike trains as output. A single spike is nothing but an event occurred at a particular time on a certain space. Got it? Here